we need to we need to put the number on the parent chain. Okay. Why we need to put the number? Because so that we can tell whether where is the double bond, where is the triple bond. Okay. Where is the methyl group, where is the ethyl group, where are the substituents. Okay, that's what we need to consider. Got it?
Yes, sir.
So numbering, from which end should we start the numbering? What's the rule says?
With the closest of double bond or substances.
Closest to. Sometimes there is a competition between the double bond, whether you should choose any one of them. Should it be closest to the double bond or should it be closest to the substituent? Got it? That's what we need to discuss. Okay. So if yeah, Ma, good evening. Am I audible?
Good evening, sir.
Yeah. So just we were trying to figure out how to select the longest chain, how to number it. Numbering is done from the end which gives lower number to the carbon atom containing the double or a triple bond. Okay. Double, triple bond, Nabila, are given more priority than the
Okay, sir.
substituent. Okay. So let's try to name this compound. First, we need to select the longest possible chain containing maximum number of carbon atoms.
Pentene.
That is pentane. Pent. That is of 5
Is it
carbon atoms. Yeah.
for
Tell me.
dimethyl?
Yeah, but should we start the numbering from this side?
No, other side.
Yeah. Why?
Because the double bond is closer over there.
Yeah, double bond. We need to give the priority to the double bond. Clear? Not to the substituent first. So it is 4-methyl. Pent 2. Got it?
Yeah.
What is the name of this compound? Yeah, tell me.
2.
Word root is 5. So it is pent. Now for the suffix, primary suffix, we have two candidates. Got it? And who are those two candidates?
Double bond and triple bond.
Yeah, double bond and triple bond. Okay, and if we need to do the numbering from the end which is closer to the multiple bond. Okay. So pent 1 in 3 ion.
So can you, why did we do double bond more than triple bond.
No. If there are two sides, okay, the numbering is done from the side which give lower number to either
So
double
double
bond
bond
or
is
triple
more.
bond. Got it? Either double bond or triple bond. From wherever you are getting the lower number, you will do the numbering. Got it? It can be to the triple bond also. Is it clear?
Yes,
Yeah.
sir.
But if they are equally equidistant, then the double bond is true. In this case, they are not equidistant. This is closer to the end. So I started numbering from this side. But if they are at equal distance, then I choose double bond over triple bond.
Okay, sir.
But what student remember, they always do double bond. No, not always. Whosoever is closer to the end will given more priority. Got it?
Yes, sir.
So, and if they are at equal distance, then the double bond is chosen over triple bond. So, what is the name of this compound? Numbering. For numbering, I will choose this side because
Can
double
you
bond.
pent I in
Hmm,
4
yeah,
in?
exactly. And while naming in the suffix in is written before ein, irrespective of the number. Okay, pent one in and four ein. Got it?
Yes, sir.
But let's say if it is like this,
X 1 in and 3 in
from where should we start the numbering?
from the right side.
Yeah, 1, 2, 3, 4.
And then in front of it will be 4 methyl.
So 4 methyl hex.
Six.
Yeah, what should I write now?
1
One
in.
No,
one.
in is so if both in is written first and then ein is mentioned. Got it?
Okay.
Oh,
So 3 in,
Yeah,
then 1
3.
in.
Normally we write in, okay, because ein, though it is starting from y, but that it sounds like a vowel, so you don't write two vowels together. You drop this. Got it? E
Yes.
okay, sir.
and one ein. Got it?
Yes, sir.
Now we need to move toward the IUPAC nomenclature of the compound containing function. Nomenclature of the compound containing functional group. Okay. So there is a list of organic compounds. And there is also a priority order. That if the priority order comes into picture if there are multiple functional groups. Got it? And if there is a single functional group, then it is not a problem. Got it?
Yeah.
Yes, sir.
And I am writing the functional group in decreasing priority order. Okay. So which functional group is this? Name of the functional group. Then you have prefix and suffix.
The carboxylic acid.
Name is carboxylic acid. Prefix is carboxy. Okay. And suffix is oic acid. So each functional group most of them are having two names, prefix and suffix. If the functional group is the senior functional group, means but normally your duty should be to remember the suffix. Got it?
Yes.
So your first duty is to remember the suffix. Okay. So this is which functional group? Sulfonic acid, right? Exactly. And the prefix is sulfo. And the suffix is sulfonic acid. Got it? Then if we proceed ahead, we have other functional groups in decreasing order of their priority. The priority comes into picture if you have multiple function groups. But if you do not have multiple function group, if you have just one function group, put the suffix. That's it. Secondary suffix at the end. Got it?
Yes.
So this is carboxylic acid derivative. And this functional group is known as carboxylic acid anhydride, or simply the acid is the most common acid is carboxylic acid in organic chemistry. So acid anhydride means carboxylic acid anhydride. Got it?
Yes, sir.
There is no prefix to it. The suffix is oic anhydride. After carboxylic acid anhydride, we have esters. Esters, carboxylic acid have OH. Esters have O and alkyl group on it. So these are esters. The prefix of the esters are or alkenyl oxy, depending upon their structure. But the first duty is to remember the suffix, that is OAT. Okay. I will explain it how to apply. Okay, so don't worry about it. Okay. You have acid chloride. Okay, these are all carboxylic acid derivative, if you remember. What carboxylic acid derivative means? It means that they are prepared from carboxylic acids by putting some other group in place of OH. This was the carboxylic acid. You can see. To put some other group in place of OH. Got it? It become a carboxylic acid derivative. If you put alcohol, it become ester. If you put any other carboxylic acid, it become a nitrate. If you put Cl, that become acid chloride, or the complete name is carboxylic acid chloride. Got it?
Yes, sir.
And there is a prefix, there is a suffix. Suffix is oil chloride. OYL. Got it? No need to worry about the multiple function group, because in class 12th we have the carboxylic acids, aldehyde, ketone. So there also we are going to discuss the nomenclature in each chapter individually. Okay. So don't worry too much about the nomenclature. Okay, but you need to know the basic idea. And basic idea is very simple. And I'm going to give you the list of all the function group. And with examples, we are going to try some complicated examples also. And but if you proceed systematically, you will notice that the naming becomes very easy. Though the structure may look very complicated at first sight, but when you try to solve it, you will find that it is going to be very easy. Got it? Is it clear? So this is the prefix is chlorocarbonyl. Then you have another carboxylic acid derivative, amide. So let me write it first. It is known as acid amide or carboxylic acid amide, which is the complete name. Got it. The prefix is carbamoyl. Okay. And the suffix is amide. After amide, we have another functional group which is known as C triple bond N. It is a functional group which is known by the name very famous cyanide. It is also an ionic salt, potassium cyanide, which is a very strong poison. Okay. And if it is the principal function group, the suffix which is put at the end, its name is going to be put as nitrite. And it is also known as cyano. Got it?
Yes.
So
Yes,
just
sir.
let me write and then we will discuss what is their meaning, how to apply them. Don't worry about the applications. As of now, I will explain them. Okay, next is After CN is known as nitrile. A prefix is cyno. Then you have a similar group which is known as NC. Okay, this is as if somebody has put the cyanide in a reverse manner. It's known as isocyanide. Isocyano. Okay.
Mm.
Carbonitrile. Got it.
Yes.
Not carbonitrile. This is known as isonitrile. Got it.
Mm.
But some places you can see the less common name as carbonitrile also. Got it. This is less common, so I have written it afterwards. Now, after this, we have a very important function group. This is known as aldehyde. It is known by the name, prefix is formyl. Or oxo. And the suffix is al. Then you have another very closely related functional group to aldehyde, which is ketone. Ketone has carbon on both the side. Aldehyde has H on one side. Okay, at least, and a carbon on the other side. Right? Ketone. It is, if it is prefix, it is known as oxo. If it is suffix, it is known as on. Got it? Then we have alcohol. Alcohol is OH. I'm just writing, not explaining. Okay, so don't worry about it. I will explain it once I complete the list. The prefix is hydroxy. Got it? And the suffix is ol. Is it clear?
Yes, sir.
Then you need to first remember these suffix. Okay, that is the first priority. Suffix is the first priority. Just like alcohol, this is thiol. Okay, not very common. You will see not many questions on it. Not at all. Okay. It is known as mercapto. Okay, prefix and thiol. Not required at all. Okay, you can afford to skip it. But you can't afford to skip amine. The prefix is amino. Suffix is amine. Got it?
Mm.
So these are some of the prefixes of some functional groups. Okay. Yes, you can take the screenshot of this. Is it clear? And this is also the decreasing priority order. Clear?
Yes, sir.
So how we are going to use this list? That is very important. Okay. There are some functional groups which are always written as prefixes. Like halogens, ethers, nitro compounds, halogens are written as halo, ethers are written as alkoxy, and nitro compounds are written as nitro as prefixes always. Okay. So they don't bother us much. Okay, clear? Getting my point? Who is going to bother us much? These are going to bother us. Okay. In this, which functional groups are most common? Carboxylic acid, sulfonic acid.
alcohol,
Okay. Yeah, alcohol very important. Acid chloride, right?
ketones,
Yeah, aldehyde ketones, exactly. Very important. Aldehyde and ketone both alcohols and amines. These functional groups you should remember. So this is some of the basic list of the functional group priority sequence. So now let's start with the naming. Okay. So suppose if I have this thing, suppose if you have uh, this compound. So the first thing first, and that was selection of parent chain. That is, we were doing every time we were doing this, right? Selection of parent chain, right? So let's select the parent chain first. What was the definition for the parent chain? And how are we going to select it?
the longest
It is the
chain with the
longest chain.
parent chain.
Yeah, longest carbon chain. Yes.
And if
But
it's equal, it should start from the where the branch starts.
yeah. So now there is a concern in this question. Okay, I can ask you which is the longest carbon chain first of all, and which is the parent chain. Are you getting my point? Do by if I'm trying to ask you this, does this have both questions have the same answer or different answer? I am asking you two things, or I can put it in another way. That is,
The same thing.
yeah, is it the same thing or different thing? longest chain and the parent chain in this molecule. Many times it is just the same, but some other times it may not be same. So today we can make out when it is same and when it is not same. Okay. So which is the longest chain and how many carbon atoms it contains?
Longest one has 5 carbon atoms.
Yes, absolutely. This is going from left to top, right, Nabila?
Yeah.
And which is
Yes.
the okay? Which one is the parent chain?
That is
Hmm?
That one
it's
only,
zero
right?
even
Yeah, parent
straight
chain,
line.
the main chain that should contain the principal function. Got it? It should have that principal function group. Okay. So the longest chain is this one. It is a 5 carbon atom. But the parent chain is not that one. It is this one. Getting my point? Because
The
we are
longest chain is the one
yeah,
with
longest chain.
substituent, right?
Yeah, longest chain is this one. Got it?
Yeah.
But if that was the longest, why we have chosen this? The one in the box has this is having 4 carbon atom. That was one having
Because
5
the
carbon.
primary should have the functional group included.
Yes. So this is so we are talking about the nomenclature of the compound containing functional groups, right? Clear.
So aren't we taking it like right to up?
Right to up, that could also be an option. How many carbon atoms are there?
Same amount as the one that you just.
Yeah, same. That is just the same. And ethyl is a substituent. And if you move from horizontally, then also the ethyl is at the substituent at the same position. It doesn't matter at all. Got it?
Okay.
It's exactly same. Nabila, is it clear or not?
Yes, sir.
So we need to take the main chain, which is having the maximum number of principal function group and multiple bonds. Okay. And this is the parent chain. So let's try to uh, write the name one by one now. So what is the word root? Word root is the number of carbon atom in the parent chain. Got it? Yeah, but I agreed.
Yeah.
Now the primary suffix just after the word root.
Usually
That
butanoic acid, right?
yeah, butanoic acid. Butane or oic acid. Got it?
Yeah.
And now the numbering, we need to number it to tell where the substituent is. From where should we start the numbering?
Right side.
Who should get the lowest number?
The substituent.
Not the substituent. Substituent is come later. We are doing the nomenclature of the compound containing functional group. Got it? Clear?
Maybe left to right.
Yes. So we should give the lowest number to the carbon atom bearing the functional group. Got it? No matter by doing so, the substituent may be getting higher locant. Don't bother about the substituent. You should first bother about the function group. Okay. So
Okay,
2
sir.
is high. Got it? 2-ethyl butanoic acid. That's what its name is. Got it?
Yeah.
Yes, sir.
Next compound. So this one, which one is the parent chain?
COOH, then CH,
Yeah,
CH, double bond CH.
This is going to be the parent chain, right?
Yeah.
Clear? And now, from where should we start the numbering? We should give double bond the lower number or the functional group lower number? For the
Functional
substitute
group.
lower number. First, because we are dealing with the functional group, so we should give lower number to the functional group. Got it?
Yes, sir.
1, 3, and 4. Yes. Clear?
Yes, sir.
So now, what's the name? Now you can easily write a name. But 3 in 1 oic acid. Is it clear or not?
Yeah.
The
We
substituent of
didn't mention,
pardon?
we didn't mention one in the previous one.
Yeah, if
One
yes,
oil acid.
one can be normally omitted, right? If there is no confusion. Okay, if nothing is mentioned, it is one, right? Actually, the rule says if there is no other locant, you can skip one. Got it? Okay, but you
Yes,
may
sir.
find somewhere one written. Okay, so but 3-enoic acid also can be written. Got it? Next is what about the side chain?
2-methyl.
Methyl, 2-methyl. Got it? What about the next function? This compound is very common. You might have studied in class 10th, and this is present in tomatoes, right? Acid. Okay. In acid base chapter, you might have studied, right? Oxalic acid. You might have done the titration in the school with KMnO4 and oxalic acid. Got it? So tell me the common name, but that is a common name. You can't write it here. IUPAC.
So,
This is
ethanoid.
yeah. There are 2 carbon atoms. In but is it one oic acid or there are 2 positions oic acid?
So,
How many? Yeah, where they are on 1 and 2.
between 1 and 2.
1, 2. There are 2 dioic acid. Got it?
Yes, sir.
Yeah, very simple, right?
Yes, sir.
So how ethane came?
Because it is the word root for the number of carbon atoms.
Yeah,
And
shouldn't be like ethyne or something?
yeah,
Because two carbon, two hydrogen.
exactly. So, but you should look for the nature of bond between the carbon-carbon atoms. Clear?
Okay.
So carbon-carbon bond is single. So that's why I've written in. Clear?
Yes.
Suppose if I have given this compound, what will be the name of this compound?
We should number it first.
Carbon atom you will count, right? How many carbon atoms?
Mhm.
4.
Four.
But now I'm going to
Iron.
put, but where the ion is on the second position. But 2 ion. Got it.
Mm.
And now the suffix 1 and 4
Mm.
have the principal function
Dioxide.
dioic acid. Is it clear?
Yes, sir.
Yes.
But 2 ion 1 4 dioic acid. Got it?
Yes, sir.
Now very now this is bit tricky. Okay. So let's try it first and then we are going to sort it and make it simple. Select the parent chain.
Seven
The circle.
Yeah, which is connected to the principal function group. Yeah, this is the parent chain. How many carbon atoms are there in it?
and 7.
No, in the circle.
6.
Yeah,
So
6.
hex.
Yeah, hex.
But functional group we don't
Yeah,
put
now
it.
yeah, exactly. So both of you are saying something correct. Okay, now there is a bit problem. And you have already gauged the problem. Okay. So cyclo can I call it hexanoic acid? First of all, there is a prefix
Yeah,
also.
it was
Cy-
cyclohexanoic acid.
yeah, okay. Cyclohexanoic acid, if we write, if somebody read it, cyclohexanoic acid, right? He might think that okay, this is having 6 carbon atoms, right? Got it?
Yeah.
But the molecule is having 7 carbon atoms.
Mm.
But
Okay.
that's obvious due to the oic in it, right? That there will be an extra carbon.
Yeah, OIC doesn't include that extra carbon. Look here, that OIC is not including the extra carbon. The extra carbon, the carbon were included in the word root, and that extra carbon was not the part of OIC. Got it?
Okay.
Now, can we call it as cycloheptanoic acid because it is having 7 carbon? So, if we write
Yes.
that, somebody read. Uh, who is reading this name cycloheptane, he might think that okay, there is a 7 cycloheptane. What message it communicate? That there is a 7-member ring. Got it? Cycloheptane. But this is a 6-member. Got it?
Yeah.
Mm.
So cycloheptanoic acid is also incorrect, and cyclohexanoic acid, if we call it, we are missing one carbon. Okay. So we will call it cyclohexane. Oic acid, if we write, okay, if we write oic acid, then there is a problem. The problem is we have missed one of the carbon atom. The molecule has 7 carbon and we have missed it. Got it?
Mm.
Yeah.
Cyclohexanoic acid. Mm, but we can very quickly correct it if we include some special suffix which also contain the information of the carbon. So we are not going to write oic acid. Okay. So I will write it and I will cut it. Okay. So that you can make out. Normally we write it like this, right? Agreed or not? Normally till now. But we were writing oic acid because we have included all the carbon in the word root. Okay. But there is a problem here. Okay. If we write oic acid, we have not included the carbon atom. The cyclohexane is there. So we are going to uh, include a special suffix, okay, in the cyclic, that is carboxylic acid. Got it?
Mm.
Is it clear or not? Cyclohexane.
Yes,
Now
sir.
there is a hexane and carboxylic acid include that COOH. Okay. Oic acid.
Okay.
Okay. So this is the special suffix which is used as the functional group is directly linked to the cyclic chain. Got it?
Mm.
Next is let's try to name some of the esters. Okay, some carboxylic acid derivatives. Okay, carboxylic acid sulfonic acid is very simple. Okay, because there is no, that is just SO3H wherever it is. Okay, butane 2 sulfonic acid, butane 1 sulfonic acid, wherever that SO3H, you can write it. Okay. Let me try to figure out the name for carboxylic acid anhydrates. Okay. So
So,
how
sir,
anhydrate?
but
Yeah.
the hexane is not heptane.
No, it is not heptane. Because suppose if I write cycloheptane, somebody may misinterpret it. Okay, because if I write cycloheptane, somebody may misinterpret and think that the ring is 7-membered. Is the ring 7-membered? The cyclic one? Is it
No.
a hexagon?
No.
It is a hexagon. So I should write hex, cyclohex. Okay. But if I write it,
Mm.
I'm going to skip one of the carbon atom. Got it? So I should write carboxyl.
Yeah.
Got it? So next is suppose if we have acetic acid, right? This is acetic acid. All of you are aware of, right? It is present in vinegar from class 10th. Also, you know this is acetic acid, and when you heat it, what happens to it? Okay. When you heat it, 2 molecules of acetic acid get combined together, and a water molecule is in. And that's why it is called anhydride. Anhydride is something which is formed by the removal of water molecule. Got it?
Yeah.
Is it clear? This one, anhydride. So this is anhydride of which acid? This is carboxylic acid derivative. If you put water, it will again break into two corresponding carboxylic acids, right? So I would like to ask, this is the anhydride of which carboxylic acid? And what was the name of the parent acid? First, try to figure out that. The common name is already, you know, acetic acid, and this is acetic anhydride, right? Common name. Got it? If I try to figure out the IUPAC name, what is the IUPAC name?
Carboxylic acid only.
Hmm?
It's carboxylic acid only.
Yeah, IUPAC name of
It's
the
like the
parent
product.
acid. Yeah, ethanoic acid, right? Clear? So this is anhydride of ethanoic acid and it is called ethanoic anhydride. Got it? Clear?
Yeah.
Yes, sir.
Ethanoic anhydride. Okay. But there can be two different acids. I should write the name of the acids, just like propanoic, ethanoic, or in alphabetical sequence, ethanoic and then propanoic. Okay, but I should not write the acid. Got it? I should write anhydride. Is it clear?
Yes, sir. Before the first part, you wrote two.
Because in
For
anhydride,
balancing.
yeah, suppose if I write this, okay. So this is also anhydride, but actually you can see the two parts are different. Got it?
Yeah.
Can you see it?
Yes, sir.
So now tell me what is the name? What is the name of this anhydride? So first try to figure out the name of the acids.
There are carboxylic acid only.
Okay.
Yeah, what were the name of the oic acids?
Propanoic.
Hmm? Yeah, this is propanoic, okay, but now it is not acid. Earlier it used to be acid when they were separate, okay. So, and this was ethanoic, got it? So I'm going to write it as ethanoic, propanoic, I will not write acid, okay, just oic, and instead of acid I will write anhydride. Got it?
Yes, sir.
Is it clear?
Yeah.
Yes.
It's very simple way of naming anhydride. Just try to figure out what was the name of the parent acid from which the anhydride is made up of. Got it? Instead of writing acid, don't use the word acid. Just write the name up to oic. Okay. And if they are different, you have to write both the name. If they are same, just you have to write one name and then put the N at it. Got it?
Yes.
Very easy. Now we have esters. Esters are very important and very confusing also. How esters are prepared, first of all, because naming can help us if we look into their formation. How esters are made?
By
This
esterification reaction.
esterification reaction. So what are the two components which you mix together?
This alcohol and then the acid, right? Carbolic acid.
Yeah, carboxylic acid and the alcohol, you heat it in the with the concentrated H2SO4, okay, and that concentrated H2SO4 act as a catalyst. It removes water, okay, and the carboxylic acid and the alcohol are joined to each other after the removal of, okay, got it, clear.
Yeah.
So we have this as ester. Okay, the alcohol, the alkyl group of the alcohol should be treated as a substituent. Got it? And it should find its place in the prefix. It should be treated as a substituent. Getting my point or not? What was the suffix for ester? So let's try to get back to the table. Okay. What was the suffix for ester? Suffix.
OA.
O8, right? Means word root, primary suffix, and secondary suffix. Okay, that's the main part of the name. So what should I write? Which is the parent chain? This should be treated as a substituent. Okay, this is not the part of the parent chain. The parent chain is this chain ester because it is from the carboxylic acid. Carboxylic acid, the parent chain is the one that contains CO. So this is also the parent chain. Got it?
Yeah.
So now tell me. So what is
Ask me the
the
name.
yeah word root, primary suffix, secondary suffix, and ultimately we are going to reach up to the full name of this compound. Got it? Just a second, I think this. Yeah. Hmm. Yeah, tell me. Word root. Which is the word root?
Pro somehow. Pro.
top or eighth?
Eighth.
Longest continuous carbon chain.
Eighth.
Is it continuous?
No.
No, it's not continuous. Okay, how many carbon are continuously there?
2.
Hmm? Two only. So
Two.
eighth. Exactly. Eighth. In and O8. Clear? Ethanoate.
Yes, sir.
Where this methyl is going to find its place?
In the starting.
Yeah, it is treated as a side chain or a substituent, methyl. Methyl ethanoate. There is no need to put the number because it is on oxygen. So first you need to write the name of the carbon atom containing to the oxygen and then the parent chain. Okay. And primary suffix and secondary suffix. Is this clear?
Yeah.
Got it? So these esters are very important concepts and most of the students find difficulty in naming them. Let's try to write the name of some more esters. Esters, what is the characteristic? Instead of COOH, you have C like this. So let's try to name this ester.
Butane.
Yes, but in or ein.
Two. Then.
Yeah,
You
yeah,
have to number them.
yeah. Number for starting from the principal function. Got it?
Yes.
But 2 E and O8 or 108. Got it?
Yes, sir.
One normally it is, if it is alone, it is skipped. If some other locant is there, it is mentioned. Okay. But 2 E 108. What about that CH3?
Methyl. Methyl.
That is going to come in the prefix methyl. Got it?
Yes, sir.
Next, you have acid chloride. Acid chloride, the suffix was oil chloride. Acid chloride, in place of OH, you have Cl. Same procedure we are going to follow. First, we are going to find the principal function group and select the longest chain containing maximum number of principal function groups and multiple bonds. Then we are going to decide the word root, primary suffix and secondary suffix. And then in the last, we are going to put the prefixes. Got it?
Yes, sir. So Propanol chloride.
Yeah. One,
Methyl propanol.
yeah, 1, 2, and this is the third carbon, not that one. Okay. I'm going to choose the parent chain, which is, though here it doesn't matter if you go there or this side, but it can be a matter of concern if you have different groups. Okay. So this is the parent chain. Okay. Or I can put, make it bigger to let you decide which is the parent chain. So the one which contain maximum number of principal function groups and double bonds. Got it? Multiple bonds. Maha, is this clear or not? Nabila, Maha, both of you. Clear?
Yes. Yes, sir.
So longest chain was going that side, but this is, we need to take the parent chain. Okay.
Mm.
Prop to in one oil. So right. And on second carbon, what you have? What is the name of the substituent? This is,
It could be methyl.
this is of 3 carbon atom. 2 propyl. Got it?
Yes, sir.
So 2 propyl, prop 2 in 1 oil chloride. Getting my point?
Okay, sir. Yes, sir.
Then you have amides. Amide, just like sodamide, you have some functional groups are exist in the form of salts also in inorganic compounds. NH2, and when they are part of organic, they are treated inorganic compounds. So like amide is CONH2. Got it? This is also carboxylic acid derivative, where the OH is replaced by NH2. So what is the name of this compound?
Mm,
What root is it? Right?
Methyl with an amide.
Ethanamide, yes. I will not put 1 because this is just a single functional group.
Mm.
Got it?
Yes, sir.
Okay.
Methyl.
Which is the smallest amide and what is the name of that smallest amide?
So the methyl
Methamide.
is that
Smallest amide.
CH3.
Yeah, CH3, or which is just of 1 carbon atom. Yeah. So, Maha, what is the name?
Methamide.
Yeah, formic acid. It is amide of formic acid. If we try to write the common name, okay? Common name is formamide. Okay, it is amide of the smallest acid, which is the formic acid, formamide. Got it? But IUPAC name is that methane
Amine.
Nabila, is this clear or not? Methanol.
Okay, sir.
So these are all the carboxylic acid derivative, very simple to name. Okay, esters can be confusing because you have the carbon atom on two sides, ester and anhydride. Okay, anhydride, treat them as separate acids, name them. Okay, but don't put the word acid. Just write it up to OIC and OIC in alphabetical sequence, and at the last you put anhydride. And esters also, I told you to take care, right? Now we have a very important functional groups. They are like brothers and sisters, okay? Aldehyde and ketones, right? Here.
Yeah.
So after amine, you have that CN also, but CN is not very common. I can take some example. Then you have aldehyde and ketones. CN is so what is the IUPAC name of this compound?
So which one should we take as a primary one?
First select the
Like
longest chain.
the first part,
Yeah, which one?
the
And what is the
functional group,
word root? This one?
pen. No,
Or the one which is coming from up and going toward the right hand side?
yeah, this one, sir.
Yeah,
This
this one.
because it is having the
Function.
principal functional group and maximum number of double bonds or multiple bonds. Got it?
Yeah.
Yes, sir.
So word root is 5. Okay, pent. From where should we start the numbering?
Functional group.
Yeah, functional group carbon. That should be given lowest rotate. Pent 4
4.
in. This is the primary suffix and the secondary suffix is the functional group. 1 nitride. Got it?
Methyl.
And on position 3rd, and for each you need to write a diameter. Got it?
Oh, okay.
Is it clear or not?
Yeah.
So why is it dimethyl?
Because on the
Okay.
third position you have two groups coming out of the main chain. Okay, so each one, if they are same, we will not write them twice. We will use dietri tetra. Okay, but we should put
Okay.
the number. Okay, 3. Got it?
Yes, sir.
This is nitrile, or suppose if I give you this one, What is the name of this compound? Butane nitride. And now where we have all the substituents. We have the substituent on second and third position. And they are all same. Okay, so I will put their numbers together to right. And
Yeah.
what should
Yes.
what should I write?
Trimethyl.
Trimethyl, exactly. Okay. 2, 3,
Yes, sir.
butane nitride. Got it?
Yes, sir.
Now aldehyde and ketone. Aldehyde and ketone very common, very important function. Okay, the smallest aldehyde is of one carbon atom, and the aldehyde, the suffix is al, that is methanol. Then you have ethanol. This is methanol. Okay. This is ethanol. Propanol. In aldehyde, it is compulsory to have the carbonyl or C double bond O at the end so that you can have
Okay.
H. Okay.
Yes, sir.
If it is in the middle, it will become a ketone because then you will have carbon atom on both the sides. Suffix is al, so this is propanol, butanol. Okay. So let's try to name the aldehyde. It is written in condensed manner as CHO. Okay. So what is the name of this aldehyde?
And 4N.
So
And
first of all, I'm going to
4NR.
start with the number. This is a principal function group 1, 2, 3, and 4 and 5. Got it? Because that has double bond.
Yes.
Okay. So this is the parent chain. Yeah, parent 4 in 1 al. Right. Pentanol. Okay.
Yes, sir.
Normally, if I don't put the these locants, it will be pentanol. Earlier, the locants were used put before the names. Okay. 4 pentanol. Okay. Nowadays, we put them just adjacent to the part to which they are related. Got it?
Yes, sir.
And on the second position, you have two groups which are jutting out of the parent chain. So 2 and 2, but I can't write them together, okay, because they are different. If they are same all methyl, I can club. So 2 ethyl, got it, and
Yes.
2 propyl. So sorry, methyl. Right? 2-ethyl, 2-methyl, pent, 4-1 al. Right? Is it clear?
Yes, sir.
Ketones have similar structure. Exactly, they are like brother sister functional group, but the double bond O is in the middle. Okay. So you have carbon atoms on both the side. So let's try to name this. So first complete the word room and the suffixes. Then bother about the prefixes. Got it?
Yes, sir.
Cyclohex, numbering 1, 2, 3, 4, 5, 6. Here there is not a problem that the carbon atom is sitting outside. Okay, it is the part of the ring, so we don't have that problem which we faced earlier. Cyclohex 2-ene 1-O. Got it?
Yes, sir.
And now bother about the subsequent or the side chains. So on second carbon, third carbon, and fourth carbon. So on the fourth carbon, we have 2 ethyl groups. And on the second and third carbon, we have methyl group. Cyclohex 2-ene 1-O. Clear?
Yes, sir.
Okay. So let's complete it in the next class. We